in this discussion video, we're going to do a practice problem finding the domain. So in part A, I want to find the domain of f of x equals x minus 1 over 9 minus x squared. So I want to give you 2 minutes to try this first on your own. So pause it in 4, 3, 2, 1. Pause that video for 2 minutes and try this on your own first. Alrighty, so hopefully you tried it for about 2 minutes. Let's talk about it together now. So remember that for these domain questions, I want to begin by thinking about the restrictions on the inputs. So are there any restrictions on the things that I can plug in, the inputs of my function? And for this function, there's one type of restriction. There's the fact that this denominator, 9 minus x squared, cannot be equal to 0. So if I rearrange this, this is saying that 9 cannot be equal to x squared. And that means that x cannot be equal to plus or minus 3. I could draw this on a number line by writing -3 and +3, putting open circles at both of them because I want to not include them in the domain. But I shade everything else because everything else is okay. The only bad points that I can't plug in are -3 and +3 because they make the denominator 0. Alrighty, so we got our number line here. Now we can write the domain in interval notation. So the first interval is -∞ to -3. Parentheses at -∞ because -∞ and +∞ are not actual numbers I can reach. So they always have parentheses. And I see -3 is not included in the domain. There's that open circle. So that means there's a parentheses there. And then union, next interval is from -3 to +3, both with parentheses. And then union, 3 to infinity, both with parentheses. And that is our domain. Alrighty, let's try part B of this question. Alright, so here is part B, this function g of x, which is almost exactly the same. I just have a square root over that fraction. So I want to begin by having you try it for 5 minutes. So pause it in 4, 3, 2, 1. Pause that video for 5 minutes this time. All right, let's talk about it together now. Okay, so let's begin by thinking about the restrictions on our inputs. And for this function, there are two types of restrictions. We have a denominator, 9 minus x squared, and that is not allowed to be equal to 0. And we've already dealt with this before in part A. And we saw that this meant x cannot be equal to plus or minus 3. The other restriction is that we have this even root. So the stuff inside of it has to be greater than or equal to 0. So the stuff inside of it is that fraction, x minus 1 over 9 minus x squared. That whole thing has got to be greater than or equal to 0. So we have this non-linear inequality. And we saw that to solve these, we can use the cut point method. So the cut point method. So let's use that. So remember, the first step of the method is to get one side equal to 0. So get one side equal to 0, but that's already done for us in this inequality. So that is already done, which is awesome. All right, so we are on to step 2. And in step 2, we find the cut points. We find the actual cut points. So remember that those are the points where the expression or our function either equals 0 or it is undefined. So let's first figure out where this function equals 0. So I'm going to take x minus 1 over 9 minus x squared and just set it equal to 0 to figure out, well, when does that happen? All right, so I can multiply both sides by 9 minus x squared, because that'll get rid of the denominator. I'm left with x minus 1 on the left and then 0 on the right. If I move over 1, I get x equals 1. I should check if this is extraneous or not, because in this equation, when I set it equal to 0, I do have variables in the denominator. So I'd have a problem. I would have a problem if I plugged it in and the denominator became 0. But luckily, I can even do this in my head. If I plug the 1 into the denominator, it doesn't make it 0. So x equals 1 is fine. It will be a solution. All right, now let's think about, well, when is our function undefined? So it's going to be undefined when the denominator, 9 minus x squared equals 0. But we've already figured out when that happens. This happens when x equals either positive or negative 3. So we are ready to write our cut points now. So the equal 0 cut points, there's just one, it's just x equals 1. And the undefined cut points, we have 2 of them. There's positive 3 and there's negative 3. So we have our cut points. So we're on to step 3, where we do sign analysis. We do some sign analysis. Okay, so I'm going to zoom it out a little bit so I can see my function. Because what I'm going to do is I'm going to make a number line. I'm going to plot the cut points on the number line. Negative 3, and then 1, and then 3. It doesn't really matter if it's to scale, but I do need to make sure that those numbers are in order. Okay, and then I want to write my function that I had, which was x minus 1 over, and it helps if I can factor everything. So the denominator, 9 minus x squared, is a difference of squares. It's 3 minus x times 3 plus x. Okay, because I want to know when is that positive and when is it negative. So now I write each of the factors of this as a row in this sign chart. X minus 1, 3 minus x, 3 plus x. I'm going to separate columns where each of the cut points is, and then rows for each of these factors. And now I have to think about where is each factor positive and where is each factor negative. So for something like x minus 1, I could do this by plugging in a test point in each region, like to the left of negative 3, I could plug in a value like negative 4. And if I plug that into x minus 1, it would end up being negative. And I could keep going like this. There's just a slightly more efficient way, which is to think about, well, when does x minus 1 change sign? It's going to change sign at 1. And if I plug in something bigger than 1, x minus 1 will be positive. So it's positive on this side. And if I plug in something smaller than 1, it is going to be negative. All right, now let's move on to 3 minus x. This is going to change sign when x is 3. And if I plug in something bigger than 3, like 10, I'll get 3 minus 10, which is a negative number. So I got to be careful there. It's actually negative on this side. But if I plug in something smaller than 3, 3 minus x will be positive. So it is positive on this side. If I do the same thing for 3 plus x, it changes sign at negative 3. And it's going to be positive on this side when I plug in something bigger than it. And it's going to be negative on this side if I plug in something smaller than negative 3. All right, so now I'm ready to form the signs of my original function. So I'm going to need to sort of multiply the signs together. In the first column, 2 negatives multiply to make a positive. In the second column, 1 negative overall makes a negative. If I have all positives, that's definitely positive. And then 1 negative is going to make a negative. Okay, now let's do open circles and closed circles. So let's see, our undefined cut points were positive and negative 3. Those always have open circles. Ooh, let's put that in a different color. Let's put it in black. Undefined cut points always have open circles, because if I were to plug them into the inequality, into our inequality, it would make the left-hand side undefined, and that would just make the inequality not true. That's why they're not included. Okay, and then those equal 0 cut points, which was just x equals 1, that's going to be closed if our inequality, which is here, has an equal sign, and this one does. All right, so I'm going to put a closed circle there. All right, and let's see, I care about when my whole function is greater than or equal to 0. So I need to shade in the parts where it is positive. So it's positive over here, and it is positive over here. And now we write down our domain. We write down what's shaded in interval notation. So we get negative infinity to negative 3 with the parentheses, union, and then 1 with a bracket, because 1 is included, up until 3 with the parentheses, because 3 is not included. And that is our domain right there.